whatsoever. You guys all know what the area of a rectangle is.
Circle.
Wrong. But if it was a rectangle, what would be the area of a rectangle?
Base times height.
Base times height, length times width. So the area of a rectangle, base times height. Does it matter which one's the base and which one's the height? No, not at all. A lot of times with areas, you see how I wrote the capital A and I put underneath it like what we call a subscript, and that's what we call, that we can denote all the different types. A square, same thing, base times height. A lot of times though, they write it as this. The area of a square is just the side squared. Because in a square, aren't all the sides the same? So your base and height would be the same, so you just say it's the side squared. Or if you want to refer to it as base times height, that's perfectly fine. But this text generally uses side squared. Okay. Triangle. Yeah, it's half the base times height because a triangle is basically half of a rectangle. Since you can draw it in, do you need paper or a pencil?
I don't need neither because I'm going to be watching it.
Don't need neither, whatever. You don't need either, but that's okay. So it's 1/2, your area of the triangle is 1/2 the base times height. And again, when you put it in the calculator, you can just do 0.5 times this times that, just string it right through, it's gonna be just fine. Excuse me. A parallelogram. What do you got for that? You should know this one. What's that? Well, true, but you should also know this one. You've done it before. It's gonna be real tricky. The only trick about this one is that your height of a parallelogram is gonna be what's drawn at the right angle. Sometimes they will draw it on the outside. Sometimes they'll put it on the outside like that with a little dotted line, and sometimes they'll draw it on the inside like that. Parallelograms, a lot of times what they do is they will use trig to make you generate what the height is. So you might have to use something like that as well, and we'll have examples of that pretty soon. So I think those first those first four, 3 of those you already knew without a big deal. The fourth one was the parallelogram, which obviously isn't really all that difficult either. Excuse me. So let's get into trapezoid. Yeah, it's like the allergy stuff. It's just all the. Trapezoid. It's half the height times the sum of the bases. Half the height times the sum of the bases. Now your height here, again, whenever I say height, the heights are always going to be drawn as a perpendicular. And then your bases are just your 2 parts out there. Again, you will see a lot of times with trapezoids, we like to throw in some trig in that, so that way you guys see how to generate the heights. Sometimes you are able to draw things out of it. As we get going with these things, we start combining a lot of them. We start putting trapezoids on top of other things. We shade them. We find specific areas of shaded regions. Then eventually we find probability of shaded regions and things like that. So that's where all this goes through. Have you guys done trapezoid before? Okay. Just wondering. It's not one I wasn't sure if it was something from prior knowledge or not. So we have trapezoid, kites, or a rhombus. I think that's a rhombus.
That's a square.
Is it a square a kite, or a square a rhombus, or rhombus a kite? It's a rhombus.
It's a square.
Rhombus
Is it swarmbus, did you say?
Smare.
Smare, yeah. We'll say this is a rhombus. We'll say we have a rhombus. I'm trying to make sure I don't skip one. And rhombi, thank you. Rhombi all have the sides are all the same. Doesn't necessarily mean that their angles and stuff are the same. But one thing we do know that in a rhombus is that the rhombus will, they're perpendicular at their diagonals. Excuse me. Skip one here. So the area of the rhombus, excuse me, it's going to be 1/2 diagonal 1 times diagonal 2. One of the things that you will see a lot of times when you're dealing with the rhombus is that since you get right triangles within it, you'll be using Pythagorean theorem quite often to find those side lines. You might be given one part, you'll have to find the other one doing that. And then obviously, or I shouldn't say obviously, but also the kite has the same formula. Kites and rhombuses, or rhombi, have the same thing, have the same formula. Rectangle, base times height, square, side squared, triangle, half, base height, parallelogram, base height, trapezoid, half the height, sum of the bases, rhombus, half diagonal 1, diagonal 2, and the kite. I think that's all of them. Yep, there's the kite. So we get to do stuff like this. We need to find the area of that object. Excuse me. Now, when you look at something like this, first thing you have to do is figure out what are you looking at. Is it a rectangle, square, triangle, parallelogram, trapezoid, rhombus, or kite? Trapezoid. Why is it trapezoid? One set of two bases are parallel, so one set of parallel bases. Okay. So we know we have a trapezoid. Now, one of the things that I would suggest that we do, especially for the first few days, write down what it is. 1/2 the height times the sum of the bases. Okay. Am I all right with that? Now, which one of those is the height? The 20, the 20, or the 16?
16.
Why is it the 16 again?
Right.
It's the right angle. So I know that the 16 is my height. So we have 1/2 of 16. What are my bases though? One of them's 20. But we have to figure out the other one. Let me move this one down. So here's what happens. What it forces you to do is that you know from here to here has to be 20. You okay with that? And if I draw that in, what's that height on that side? 16. Yep. And then you get Pythagorean theorem to find out that other chunk. So in geometry, it's not just, hey, here's all the information, put your calculator and press enter. Sometimes you do, in fact, have to do an extra step or two. Well, in this case, you're just using Pythagorean theorem. So which one's your hypotenuse, the 20, the 16, or the blank? The 20, because it's across the right angle. So you are going to have an x squared plus 16 squared is 20 squared. Okay? 12? You're going to get 12. Which means, what's what's that secondary base?
12. No, wait, it's 32.
32, because you added it in. Okay.
Did everyone recognize that with a 3, 4, 5 triple?
Nope.
This is triple also. 3 times 4, 4 times 4, 5 times 4. 12, 16, and 20. So if you recognize it, great. If not, what could you fall back on? Pythagorean theorem. Pythagorean theorem's got big shoulders to take care of you. And now it's just a matter of putting that directly in your calculator exactly the way it's written. If you do it that way, you'll be hard pressed to screw up. Not that I wouldn't put it past you, but it's more difficult. No, it's 810.
Ah, he got you.
416.
810.
416.
Okay. Where we at? You said 416? Now here's the deal. When you're dealing with areas and when eventually we deal with volumes, this is where I'm going to be a stickler on labels. This one did not have any units to it. But whenever you're dealing with surface areas, what should your units always be? Something squared. Thank you. Should always be something squared. Now in this case, since we don't have inches, feet, centimeters, or anything like that, what we do is we write units squared. Okay? Please make sure you have labeled, or you will, please make sure that you do in fact label your answers on these, okay? Yes, sir? Yeah, quite literally put it in your calculator like that. And it'll spit out the answer. All right. Sometimes you have to actually work backwards. Since we just did one with a, what do you call it? Trapezoid. Let's work backwards from solving for x. Because what fun would it be if you just had to substitute in all day long? Sometimes you have to find missing parts of them.
Yeah, I need the missing part to see from
Scare you guys.
And this is why you always want to start by writing the formula down.
Exactly. Exactly. You'll see that it's not a real scary, crazy algebra problem. There's just some stuff you just, like we're saying, just make sure you write it out. If you write it out, you're going to be really hard pressed to screw this up. So we have to figure out what the height is, knowing that you have the bases. If your trapezoid has an area of 12, half of something, 5 plus 7. What's 5 plus 7? 12. So you have 12 equals half of 12 times x. What's half of 12?
6.
X equals 2.
What's x? 2. Okay, so it's, as you see here, it's not going to be crazy. Now, one of the things that you can do, can I get rid of this half by multiplying both sides by 2? So I could have done this. 24 equals 12x, and I would have gotten the same thing. Either way, you're still going to get x equal to 2 and x equal to 2. It's very, very simple. Right? There's not a lot of crazy. It's just a matter that you just need to know what you're looking at. Okay? What are you looking at? You get the one with the trig in it.
You just want to figure out X or the area.
That was just solve for x, because it gave you the area and it was asking you to find the missing part. That's all. Let's see if this works. All right. I apologize for the line drawn through the middle, but yeah, we have a kite. All right. what happens with the diagonals of a kite? What do you get? When the kites intersect each other, what do you get? Not kites themselves, but the diagonals of the kite. When you're right about I meant where the two diagonals intersect. What's created where the two diagonals intersect in the kite? Right angles. Okay. Now remember, in a kite, you get right angles here, and the part that's between the two angles here, that diagonal is bisected. Okay? So what we need to do is figure out one of the missing parts. Now, if you look at this, you have a right triangle here that you know that this is 16. There's your 40 degrees, and you need to find Yay Sokotoa. When you are at your 40, what are you looking at? Your opposite. 16 is your, what trig function is opposites and adjacent? Tangent. The tangent of 40 is x over 16. Pretty good idea. Sokotoa. Okay, we can put it on a smart board and come back to this. And then if you remember, there were only two ways that you had to solve these problems. Either your variable was in the numerator, or the variable was in the denominator. And we wrote it like this. Trig angle is x over number, or trig angle is number over x. Usually that our problem was always worked out to be one of those two steps. And if it was, we found very simple ways to solve it. If our variable was in the numerator, all we did is we multiplied whatever the denominator was, that number, times your trig angle to get x. Or in the other case, we did the exchange-o changer. Okay. That was basically all the important things as far as equation stuff was concerned in terms of trig. It was either going to be one of those two. It wasn't very often, well, I should say this, in working with areas and stuff, it's very rare that we have to worry about finding the angles. Okay? It's very rare that we have to worry about finding the angles. A lot of times you're going to be given an angle to get there. I can't remember a single problem, to be honest with you, that you have to do that. So that's a good sign. Kind of, no pun intended. No pun intended. Get a little fresh air in you, you don't know what you're doing anymore. Okay. So that's where the trig stuff goes. So revert back to a second ago to where we were at, or hold on, I'll give you guys a second to write that down. I still see something feverishly writing. Excuse me. So if we go back then, we all right? No worries, no worries. I had this on feverish. That's I said feverish. squirrel. So here we have our variable in the numerator. So all I have to do then is just multiply out by the denominator, press a couple of buttons.
You would do that? 16.
So you have to make sure that your calculator is in degree mode, which it should be, because I don't think we've done anything that has that we have never had to. But just in case you've accidentally dropped it or something along those lines, just type it in. Once again, I need you guys to constantly try to go to 2 decimal places. So if this is 134255, it would be 1343, okay? Which puts us back up here. To do that. So finally, after you go through your trig, you can go ahead and use the formula for the tractor, or excuse me, the kite. So your area of the kite, half diagonal 1 times diagonal 2. So it's 1/2 of 8 and 16 is 24. Times 1343, 13 will be 26. 2686, and just multiply it out and round it out to 2 decimals again. So yeah, sometimes you have to do a little extra math to get to it, but it's kind of all review of math that you've done. It isn't anything really. The only thing that's new it might be just that formula. How you use it, it's all the same. Okay. Right? What'd you guys get?
322.
What? 322 what? Yeah, we didn't have units, we just say units squared. Yay.
Are we gonna work with 3-dimensional cubes or just 2-dimensional?
In chapter 12 we do.
Okay.
Yeah, we go to 3-dimensional, and then they just get a little weird. Because you have to find the area of a base, and then you multiply by this, and this. It's formula work. Trying to think if there's any other goofiness here. Probably not. So, excuse me. Now, I will post these two onto the calendar. I think I originally only had the first worksheet on there. But I'll put up the 11-2. We'll do both parts here. You just put them on the same sheet. And do those things through. Okay. But yeah, I know I have the 11-1 on there. I might have to move the 11-2 on there as well. I'll do that real quick.